What does it take to deploy an AI agent in production? In the first few months, I have created a couple of AI agents. Each of them was a prototype. It helped me with learning of how to build an AI agent using Python frameworks such as LangChain and LangGraph. Building an agent is not the end goal. The end goal is to deploy an AI agent in production and start using it, which I had not done earlier. I mainly focused on building of AI agents, but I did not go through the steps of production deployment. In order to go through the steps of production deployment of an AI agent, I took an AI agent that I recently created in a notebook using LangGraph and DB2 LangChain connector, all in Python. I took this example AI agent and started converting it into a production deployment form. Notebook is good for quick prototyping because everything is in one place, so you can execute one part at a time and continuously improve and progress and complete your workflow. So this is great for prototyping, but it's not suitable for production deployment. So the very first thing I started doing is converting my notebook code into APIs. The AI agent that I used in this exercise is an agentic RAG use case. Here is a high-level workflow. This entire end-to-end workflow that I published earlier, it has two parts. In the first part, I constructed a data ingestion pipeline in which that I downloaded a document from its URL, did some data cleaning, created chunks, generated vectors, and then I stored these vectors in a DB2 database table using DB2's LangChain connector. That was my data ingestion workflow. Then I also created an agentic workflow for answering question in which the workflow would find the top matching result from the vector and the content stored in DB2. Then finally, after doing some refinement, it will give the question and the answer to an LLM with a prompt, and then LLM will generate the answer. So that was the second part of my notebook code, which is the question and answer workflow using some question and answer agentic workflow. The first thing I did, I converted all my data ingestion steps from the notebook, which starts from load and pre-process document, chunking, then vectorizing the chunks and storing them into a DB2 table. All these steps in the data ingestion workflow, I converted into an API, ingestion_API, which I published under new subfolder in my repo, document ingestion API. Let's take a quick look at the structure of this API, and I have used FastAPI for implementing this API. As you can see, I have actually copied my code from the notebook, such as generating, embedding, chunk text. I converted into functions. I have added a API endpoint ingest, which is the main function for ingesting a new document into the vector store. Then I added another API endpoint clear, which will clean up or drop a pre-existing table where vectors of the content are stored. These are the two main functions, and I have provided the code and the setup step. In order to try this out as is, you would need a DB2 version 12.1.2 where the vectors features are introduced. Now what I want to do, I want to show you a quick demo of running this API following this step. I am going to clone this repo. I go to my repo, then I click this code and copy the link to my repo. Then I open VS Code, git clone, then I am pasting the URL that I have copied from my GitHub page. Now this has been cloned. What I will do, I will go inside this folder because I want to run this data document ingestion API. So I go to the README and follow through the step. The first step is to install a set of Python packages. So I'm inside this newly cloned repo, and I from the command line I went inside document ingestion API folder. These are the files that came from cloning the repo. The first thing I am going to do is run this command. This will install a set of Python packages that I need. It will also create a Python virtual environment using UV package manager. Okay, let's take a quick look. ls. So now you can see it has also created a Python virtual environment, venv. Next, I'm going to create a models folder in my parent directory of the current directory, because these models it will be shared by multiple subfolders. For example, I'm going to use it from this data ingestion API for vectorizing the content. Also in future, when I will create a search API, then I will also need to use that model for vectorizing the query for that needs to be answered from vector search. In the next step, I'm going to install another Python package which could not be installed with straightforward UV. It helps with some of the data pre-processing steps. To this step, that was also installed. Next, I'm going to download a Granite text embedding model, and this will be stored in the models folder that I created a little ago. Okay, the model has been installed. The other thing I need to do is create a .env file in the parent directory, which is agentic rag db2. So I'll go one level up cd. So I do not have that file, so I'm going to do touch.env. Okay, so just now you can see that .env file has been created in the parent folder, but its content is empty. I need to fill this in with this value. Also, for implementing my agentic rag use case, I'm using an LLM hosted on watsonx AI. That's why I'm also going to use the project and the API credentials for using watsonx AI from this project. However, you can replace this with some other LLM provider or self-hosted LLM such as Olama or Llama CPP. For my current implementation, I also need to fill in these values in the .env file. The next step would be to run the API. For this, I need to go inside document ingestion API folder. I'm also going to create a second terminal, so that in one terminal on the left I will be running the API, and from the second terminal I'll be invoking this API. The API is now running. I can also try this out by going to this link. It shows the document the API is running. I can also try this out from here, but I'll be trying this out from the command line using this curl command. So I'll just type it on the right side. In this curl command, I will be providing an URL, which is a blog article that I have written on db2's Python UDF feature, and I'm also giving a table name. If this table AI underscore knowledge, if it doesn't exist, then the API will create it. If it exists, then API will just use the existing table for storing the vector and the content. Run it. So you can see that API has successfully completed, added 23 chunks to the existing table AI knowledge. This concludes my demo of document ingestion API that receives as input a URL, and then this ingestion API downloads the document, preprocess it, make chunks out of it, then convert each chunk into a vector using a self-hosted text embedding model, and store these vectors along with this chunk in a db2 table. I have also implemented two other endpoints which I have not demonstrated, but you can take a look. You can try this out. Another API endpoint is clear. If you run it, you can run it with two options: true. If you run it true, then if AI knowledge table exists, that table will be dropped, both schema and the content. But if you set this confirm to false, then only the table, all the records from the AI knowledge table will be deleted, but the actual table schema will remain. Feel free to try this out. Thanks for watching.